enjoying the space ride? I'm Varun Gupta. Today I'll be talking about our mouthful of title, which actually I just realized last night might have gotten us onto this stage, trying to say all that complicated the meaning of probably what we're going to show. Imagine if we would have said, better, faster, cheaper on your own. There goes 50% of revenue for Temporal, huh? I was having a talk with Summer last night, and he said, how did we let you guys present this? But here we are, and in all seriousness, we love our partnership with this Temporal team. How awesome a team they are, investing so much, not just into the cloud offering, but also in the open source community and the open source offering. Everything we will be talking about wouldn't have been possible without a good cooperation with them. So please join me in giving a big hand to the awesome Temporal team. Hey. So as I said, I'm Varun Gupta, one of the engineering leaders at Salesforce. With me today, my co-presenter, Sahil Vazirani, principal architect for software engineering, also at Salesforce. Will be coming by later. Before we start, let me remind you, and that you includes all humans, includes that most of us here, we might have some aliens from space, as well as any live AI bots or Gen AI scrapers eventually, that please make all your purchasing decisions based on currently available products and features. Thank you for being here today and taking the time to hear our story. Thanks to our partners, Temporal, as I said earlier, for providing us an opportunity to share this story with you. Salesforce is one of the fastest growing enterprise software companies with more than $30 billion in revenue. We are the leaders in innovation, culture, and philanthropy. Every innovation, acquisition, and strategy in our history contributes to a single source of truth about the customer, and we host a vast set of enterprise applications that help businesses use that information to serve their customers in the best possible manner. With that, who here had heard of Salesforce before today? Awesome size, awesome set of people, but let me tell you one more thing. There are two kinds of business application users. The ones who have used Salesforce or using Salesforce, and the ones who will use Salesforce at some point in time. These services that I was showing are hosted on our infrastructure platform called Hyperforce, which is what mostly I and Sahil work on. It's our next generation Salesforce infrastructure architecture built for the public cloud. Hyperforce enables Salesforce customers to deploy their customer experience across 17 different countries, providing more choice and control for data residency. And we enable many of these applications to manage their application workflows through a setup of locally available temporal control plane clusters across these countries and regions to maximize availability and scalability of those services. Let me tell you a story. First, by a show of hands, how many people here know what this is? How many have actually seen one in person? Good. How many actually owned one at some point in time? Yeah, it's a good set of hands. I expected a little less, but okay. So it's, well, trust me, all those people who raised hand for that last question will be the ones grooving the most at the party tonight. Okay, long time ago, and again, the people who raised their hand last, they know how long it was. My parents paid a lot of money to buy me one of these. And for those who have owned this, you know, it was a heavy thing to carry around, way heavier than our phones, which has way more music than what would fit in this. It skipped and damaged the cassette and everything. Some of you have seen, but many might not have. And it barely lasted on a set of 2 AA batteries. So overall, a fairly unreliable product. But I still love the damn thing. I lugged it around, even due to its unreliability. Now imagine if I could love this unreliable Walkman, imagine my happiness when Sahil came and shared with me that our team was able to increase availability of our temporal setup, minimize interruptions while ensuring consistent performance, and doing that over a large, very large cluster footprint, which, by the way, I'll throw a plug in for a presentation tomorrow, which some of my colleagues will present to tell you what that footprint is. A large cluster footprint, and still being able to bring down the unit cost without compromising the quality of the service. Well, at that point, I knew we had to come here and share that story with this great community and share with you how we are optimizing our temporal setup. So please join me in welcoming Sahil Vazirani, Principal Architect at Salesforce.
Firstly, I want to thank Varun and the Temporal community for giving us the opportunity to come here and share our story and help all of you learn from what we have learned over the years with Temporal and operating Temporal. So let's start with why high availability is important and why should we strive for dial tone standard. When was the last time you were using your favorite application or service, and just when you needed it the most, the service was unavailable? Let's have a show of hands. How many of you have experienced this situation? Quite a few. In today's digital age, downtime is more than just an inconvenience. For enterprise companies, this means that it's lost revenue, damaged reputation, and customer churn. When was the last time you were using a website and you populated a bunch of metadata, or you filled up a Google form, or an application-specific form, and you lost all of the data? How long before you got frustrated and you said, let's leave it, let me go to a competitor. This website is not serving my needs. In today's world, availability not just means the services are up and running close to 100% of the time, but it's also important to minimize disruptions when you're doing software updates or upgrades. Gone is the last generation of the world where having an hour of outage on a weekend or even a few minutes of downtime was acceptable. Today, we have several mission-critical app service and systems, such as using 911 during an emergency, where we want to strive for dial tone or telco-grade availability. What does this mean? This means 5 nines of availability, which is essentially you can have only roughly less than a minute of downtime every month. Yes, building high availability systems can seem to cost more upfront, but what's the cost of not doing it? What if your services go down when you're doing a big marketing campaign for your new service offering or on a Black Friday? This not just results in financial losses due to breach in SLAs, it also loses your potential customer pipe that you could get out of it. So next, I'll share with you a few issues and challenges that we faced and how you can avoid them. So let's have a show of hands. How many of you are operating or were operating self-hosted clusters at any point in time? Wow, that's quite a large fleet. So one of the key principles that you might have read in the AWS well-architected framework is stripe your deployments across multiple availability zones or fault domains. You might say, yeah, I can have this 3 availability zone architecture set up, but you get a page in the middle of the night saying that your applications are unavailable due to an AZ outage. As shown in the screenshot here, by default, Kubernetes has some built-in defaults that are very soft in nature. And these may not work for critical applications such as Temporal. You might have built a bunch of durable applications on top of Temporal, but what's the use of doing that if Temporal clusters itself cannot stay up? So as shown here in the screenshot, Kubernetes has large queues that can come in when you have large number of replicas for your service. you at times may have 5 replicas in one zone and none in the other. What this means, if the zone which has 5 replicas goes down, then you basically have lost quite a large percentage of the compute that would have served application requests. This leads to lower quality of service when this happens. So let's take a look at how we can strive for balanced application workloads across availability zones. We can leverage something called topology spread constraints or anti-affinity rules or a combination of them. What does this mean? By leveraging topology spread constraints, you can actually hint the Kubernetes built-in scheduler to override the built-in defaults. This helps you to achieve balanced spread across availability zones. Depending on how strict you want to be, there are 2 flavors of anti-affinity rules as listed here. One is called required, which is basically the scheduler, if it cannot satisfy the constraints, will not schedule the pods. Your pods will be in pending state for new application upgrades. The other one is the preferred option, in which case the Kubernetes scheduler will do its best to meet these rules, but if it cannot meet them, it will ignore them and move forward. So now you said that, yeah, I have my application balance across the fleet, but the next pitfall that you run into is unexpected pod disruption. So you're part of the server team that's running the temporal control plane. You're woken up in the middle of the night saying, hey, I'm seeing a bunch of pod restarts, and you're getting all these alerts for pod restarts, and you're wondering what's going on. There's another infrastructure team or the cloud provider that has basically marked certain nodes as unavailable and has taken down those nodes. And it so happens, even if the probability is low, that you basically stepped on this pitfall and you lost all copies of your application that were running on these nodes. So how do you deal with this situation? These situations are pretty common in nature. It could lead from patching. It could lead from cluster upgrades for Kubernetes, or it could even lead from cloud provider vendor upgrades, because at the end of the day, cloud is somebody else's server. So you need to design to run temporal control plane by keeping these failure scenarios in mind. Pod disruption budget to the rescue. Pod disruption budget helps limit the number of concurrent disruptions that your application experiences. This allows you for higher availability, but also permits the cluster administrators and the cloud providers to manage cluster nodes effectively. Pod disruption budgets help facilitate smoother rolling upgrades and other maintenance tasks, allowing you to be in control to specify the acceptable level of disruption. So you went through these 2 scenarios. The third scenario that you go through is 1 month later. You're woken up and you see a bunch of errors in the log, says certificate expired. You're like, we are using this PKI infrastructure. We have automated certificate rotation. It's not my problem. And you snooze the alert, only to be woken up 15 minutes later saying the alert is not going away. Certificate management is one of the most common pitfalls faced by application developers. And what I'm talking about here is not just relevant for the temporal control plane. It's also relevant for you if you're running temporal workers. Certificate expiration can severely impact application availability, erode user trust, and also lead to reduced security posture. Why do I say reduced security posture? Especially if you have expired certificates for your temporal UI, this can lead to various security attacks that are potentially possible. This could lead to big operational challenge and headache that you have to deal with and restore service ASAP. So how do you deal with this? You need to do 2 things. One, you need to regularly have a PK infrastructure that can renew and check for certificates that are about to expire and do this work proactively to prevent unexpected outages. That's the first part. The second part is to consume the updated certificates to ensure that the application has business continuity. Thankfully, temporal team has already thought about the situation in advance and provides this configuration support out of the box. So as shown in the screenshot, there are a few options in the TLS part of the configuration where you can put in expiration checks, specific warnings that you can receive ahead of time, along with how often should the services check and update their application context for these certificate renewals. So with these three challenges that we walked through and learned how to address them, we hope that you can now have a better availability posture for your temporal control planes. Let's walk through scale challenges next. One of your applications that are using temporal suddenly has a massive application load spike. The application team sends you multiple Slack messages saying, hey, you told me Temple provides me durability, but I'm getting all these errors in my application because my workflows are stuck. I'm not able to submit new application workflows. And yeah, I'm basically getting a bunch of bad press publicity, and you guys need to help us out. You wake up, you log into the cluster, and you see the dreaded message, killed. You're like, okay. And then you try to identify what's the impact. Your boss asks, what's the impact? You say, new workflows are stuck. I'm unable to trigger schedules. Timers are not firing. And it's a whole mess. So how do we deal with this? We need to ensure that temporal control plane can scale based on application load. You can do this through techniques such as horizontal pod autoscaler. What does horizontal pod autoscaler provide us? Provides us improved resource efficiency. HPA automatically adjusts to the number of pods in response to real-time metrics. You can use CPU, memory, or custom metrics, thereby ensuring optimal resource utilization and reducing cost by scaling down when the demand is low. So it's a win-win. It's not just a scale benefit, there's a cost benefit also associated to it. HPA ensures enhanced application performance that under varying load conditions, you dynamically are scaling pods, thereby maintaining the same quality of service to your end application developers. HPA also ensures resilience and reliability by distributing the load across multiple copies of your service, thereby preventing single point of failures and ensuring high availability during peak usage periods. So now that you've scaled your application tier, which is a bunch of microservices, you say, yeah, I can go back to sleep and everything is going to be fine. Is it? The next challenge. Temporal cluster database workloads are generally very write-heavy. There's a bunch of event history and state management. It's all done in the temporal persistent store. The persistence layer provides durability, reliability, scalability, consistency, performance, which is basically the heart of the temporal control plane. This ensures the robust and efficient and durable workflow management that you're looking for. Persistent layer is the underpin for the entire workflow execution and state management system. So running out of storage space, CPU, memory, or IOPS are going to be dangerous to support high volumes of scale on temporal clusters. So how do we address this? You can address this through multiple techniques: storage, instance auto-scaling, and proactive monitoring. We here at Salesforce use Aurora, which is part of the AWS public cloud, that enables seamless storage and compute scalability. What this means is that AWS automatically adjusts storage capacity in response to application needs without manual intervention, thereby ensuring optimal performance as data volume grows. This ensures that you don't have to deal with operational overhead of operating a database. We have persistent scaling, and we ensure that this is more cost efficient because the cloud provider is automatically adjusting our storage capacity. Thereby, we need to avoid provisioning excess capacity upfront. We save costs by scaling storage based on usage. And this helps us to avoid over-provisioning of storage, and I'll talk about how cost efficiency and storage are interrelated in a bit. You scaled your application tier and your storage tier. How many here have run multi-tenant temporal clusters with multiple namespaces in them. Let's have a show of hands. That's good. So a key principle of multi-tenancy is isolation. How can you achieve isolation? Temporal out of the box has some safe limits, but if you don't enable them, you can have one cluster namespace that can basically hog on to all the resources in the cluster, thereby starving the other users in the other neighboring namespace. This is essentially noisy neighbor problem. One particular namespace can consume excessive CPU and memory. This can negatively impact other workflows and services, and those applications can have breach of SLAs for their end users. So by defining resource boundaries, you can ensure that the system doesn't overload and crash, leading to downtime and availability challenges. By ensuring you are proactively monitoring for critical usage on your cluster, you can prevent these events from happening. So always ensure that you enable per namespace resource quotas to enable fair usage. How do you do this? Temporal provides this out of the box with something called dynamic configuration. You can set limits at the cluster level, and you can set specific specific limits as well. By alerting on critical usage, you can ensure that you proactively work with those application teams such that in case they need additional resource quotas, you're going to provide them upfront versus them running into rate limits and then paging you in the middle of the night. Finally, isolate critical workloads from the rest of the group. Do not try to put too many critical workloads on the same cluster. Before I go into how do we make our clusters cost efficient, let me tell you a joke. A developer meets a genie. The genie says, hey, I'll give you $1 billion to spend in a year, which is roughly 100 million a month. However, there are 3 rules. No gifting, no gambling, and no throwing it away. The developer responds, hey, it's pretty easy. Can I use AWS? The genie responds, there are 4 rules. So why is resource underutilization such an important challenge? Kubernetes, by default, allows you to specify resource limits. There are a few challenges with this approach. Developers typically say, let me specify some arbitrary limit. I need 8 vCPUs and 16 gigs of memory, and we'll be all good. What this leads to is resource underutilization. That if you go and look at metrics that are provided by tools such as Container Advisor or C-Advisor, you'll see that the average utilization on the cluster is probably 10% for that application. This leads to wasted infrastructure costs, inaccurate budget forecasting. So how do we solve for this? We can solve for by using these metrics to fine-tune our resource limits. And also we enable auto-scaling in the event there are sudden spikes in traffic loads. How many here want to pay more and do less? Pay more, do less? Amazon and other cloud providers introduce new generation of instance types every year. If you look at your billing data carefully, the older generation instance types become expensive year over year. So you might be thinking, hey, I have more traffic, thereby my costs are going up. If you go and observe it closely, you'll observe that you might be having a flat line in traffic, but you're probably paying more per transaction. So how do you solve this? By upgrading to newer generation instance types, you achieve enhanced performance and efficiency. You also leverage the latest industry hardware optimizations that are more compatible with the latest operating system and kernel optimizations. By regularly reviewing and adjusting instance types based on workload requirements, and leveraging cloud-provided optimization tools to track expenses, you can further identify saving opportunities. Next, walk through storage. There is a graph out there in the industry. I couldn't find the source before this presentation, but if you go through the storage evolution over the past few years, by using older generation storage types, what this will lead to is increased workflow execution time, increased cost of doing write operations, especially for Temporal, which is a write-heavy system. By transitioning to more suitable EBS volume types, such as GP3 or IO1 or IO2, you can provision the amount of IOPS that you need for higher efficiency, performance, and throughput. This upgrade helps you to meet the high performance demands of temporal clusters, reduce the latency, improve reliability, and support efficient execution of workloads under varying loads. Additionally, you should monitor EBS performance metrics and optimize volume configurations that can ensure you eliminate bottlenecks and achieve optimal resource utilization. Finally, let's talk about archival. Archival is a feature introduced in the open source, helps you to achieve compliance by having longer retention for your closed workflows. However, optimizing the retrieval of these closed workflow events and histories is important. You can do this through S3 lifecycle policies and intelligent tiering. Also, set per namespace limits on how often can users query the archival store, because if the workflows are sitting in cold storage, it's going to cost you a lot more to retrieve those workflows. So you need to fine-tune the lifecycle policies to ensure you don't blow up your prediction on forecasting for your budget. So with that, I'd like to end this talk with 3 key takeaways. We hope that we were able to share the essential knowledge that would help you to optimize your temporal self-hosted clusters, achieve higher availability and quality of service, and thereby enable your application platform teams to achieve seamless and durable workflow execution with ease and have peace of mind. Thank you.